Assalamualaikum warahmatullahi wabarakatuh and good day to our lecturer Dr. Intan Ermahani binti A. Jalil. We from Group 12 will be presenting our group assignment of Algorithm Analysis EITP 2123 under a topic of Divide and Conquer Algorithm. So this is our group members. We have 4 members in our group. My name is Nur Akila Hanan binti Azmi. My matric number is B0320101260. So next is table of content. We have 5 content. First is introduction. Second is a picture diagram. Third is algorithm. Fourth is complexity. And fifth is quick sort. So the algorithm that our group choose is a merge sort algorithm. So I will be starting my presentation by the first content, introduction. So in a computer science, merge sort is an efficient general purpose and comparison-based sorting algorithm. Most implementation produce a stable sort, which means that the order of equal element is the same in the input and the output. Merge sort is a divide and conquer algorithm that was invented by John von Neumann in 1945. It has a usual performance of O and log n. Merge sort works by dividing a given array into 2 subarrays of equal size. Then it will be sort the subarray independently using recursion. After that, it will merge the sorted subarray to get the solution to the original array. So the merge sort works on 2 functions. We have a merge function is used for merging to half. And then second, we have merge sort function recursively call itself to divide the array till size becomes 1. So conceptual merge sort works in 3 stages as follow, where first stages divide. Merge sort first divide the list into equal half and then combines them in a sorted manner. Second stage is conquer. We sort the sublist. And then the third stage is a combine. After sorting sublist, merge all sublists into a single list. So next we have a few applications of merge sort. First is merge sort is useful for sorting linked lists in O and log n time. Second, merge sort can be implemented without extra space for linked lists. Third, merge sort is used for counting inversion in a list. And fourth is merge sort is used in an external sorting. So today I will be explaining about external sorting, which is the fourth application of merge sort that I just said. So for example, we sorting a 4 GB data using only 1 GB of RAM. So we read 1 GB of data in the main memory and sort by some conventional method like quicksort. So there will be 4 chunks from 4 GB divided by 1 GB. I just name it as file 1 sorting, file 2 sorting, file 3 sorting, and file 4 sorting. Okay, so for each chunk file, there will be loaded 150 megabytes. Okay. So therefore, in a 1 GB RAM, there will be 400 megabyte free space. After each chunk, fill the 1 GB RAM by 100 megabyte, multiply by 4 and equal it to 600 megabyte. So in the step 3, we will perform a 4 ways merge and store the result in the free space 400 megabyte output buffer by taking up the smaller data of each chunk one by one. So you can see, okay, whenever the free space 400 output buffer fill, we write it and save it as a final sorted file as output 1. And then we can empty it again. So you can see that the top 4, which is file 1, file 2, and file 3, and file 4, after all the array are being filled out to the free space, it being empty, right? So we can fill it again with the next 150 megabyte from it associated 1 gigabyte sorted chunk until there is no more chunk that will be available. So all the chunk like 1 gig, the remaining of the remaining of 850 megabyte, and then we put it into the array of file 1, file 2, file 3, and then the array will be filled in the free space of 400 megabyte output. Okay, after that, after we got the output one, we have to empty it again. After we empty it again, we fill it with the continuously array and then name it as output 2. So we do the same thing until there is bunch of output file. So you can see at the step 5, we have output 1, output 2, output 3, and so on until output n. Okay, the sorted file of output 1 must have the smallest data of all of them. And then output 2 must have a slightly bigger data than output 1 have. And then output 3 must have bigger data than output 2 and output 1. So that's will be the same repetition, same thing happen until the sorted file of output n. Okay. After all the sorted file output are done, we can merge it into one big file again as 4 gigabytes. So that's how the 4 gigabyte file will be sorted in using a merge sort of external sorting. So this is example of external sorting that from the applications of merge sort. Okay. So next I will be continue with the second content, which is a picture diagram. So this is the example of unsorted data that I will be using. In the first array, we have 7, 3, 2, 16, 24, 4, 11, and 9. We divide it into half, then we check at the two part array where the left index is smaller than the right index. If yes, we have to divide it again into half. Okay, then repeat the step until we got the smallest unit after the smallest unit. So very, very small. Okay, so we have the only one unit. So after dividing the array into smallest unit, the merging start based on the comparison of elements. So first we check the data of 7 and 3, who is a smaller value. So 3 is the smaller, so 3 is filled first. And then we check with the 2 and 16, 2 will be filled first. And then after that, we have two arrays. So we check 3 and 2 because 3 and 2 is the first index of the two array that we want to merge. So we check. So 2 is a smaller, so 2 first and then 3. So we check 7 and 16. 7 is smaller, so we enter 7 and then after that 16. So that's how we got the combined array of 2, 3, 7, and 16. So we do the same thing in the right part index. So 24 and 4, 4 first, and then 24. And then 11 and 9, 9 first because 9 is smaller. And then we check 4 and 9, 4 first because 4 is smaller than 9. And then 24 and 11, 11 first because 11 is smaller than 24. After that, we got two arrays that we want to merge. We have to check, we want to merge all arrays into one array by comparing the first index of the left and the first index of the right. So we check with the 2 and 4. We got 2 first because 2 is smaller than 4. And then we compare 3 and 4. And then 3 will be the next because 3 is smaller than 4. We compare 7 and 4. 4 will be the next. And then we compare 7 and 9. 7 will be the next. We compare 16 and 9. 9 will be next, and then we compare 16, 11. 11 will be the next, and then we compare 16 and 24. 60 will be the next, and the last one is a 24. Then that's how we got the last array that fully sorted, which is 2, 3, 4, 7, 9, 11, 16, and 24. So that's how we sorted the number by using a merge sort. So I think that's it for my part. I will be pass it to the next presenter to continue the presentation. So thank you for me.
Assalamualaikum and hi, I'm Nur Khalida Kalisha, metric number B0320102224. I will be explaining the algorithm of merge sort technique. As you can see in the diagram here, merge sort is a divide and conquer algorithm. It splits the input array in half, calls itself for each half, and then merge the two sorted parts. Merging two halves is done with the merge method. The growth rate functions of merge sort can be analyzed by calculating each row of coding, and as for this case, growth rate functions or big O of the first split is found to be O n log n. Next, the numbers are then being compared when split into two halves. Hence, the growth rate functions or big O for this case is O n squared. The calculations to find the growth rate functions for this algorithm is quite simple really. In the end, you only need to eliminate the constants. Finally, you will have the overall big O for merge sort as O n log n. Next, the complexity of the merge sort technique. Sorting arrays on separate machines takes a long time. Merge sort is a recursive algorithm with the following recurrence relation for time complexity. Merge sort has a time complexity of n log n in all three scenarios, worst, average, and best, because it always divides the array into two halves and merge the two halves in linear time.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Ayesha binti Aris from section 2 group 1 as group 12 members. So for now I will present about quicksort algorithm. So for this function, it takes last element as pivot, places the pivot element at its correct position in sorted array, and places all smaller, which means smaller than pivot, to left of pivot and all greater elements to right of pivot. The algorithm of this function can be calculated as shown. So as you can see, there consists two things for calculate the algorithm, which is cost and times. So firstly, the for loop will become cost1 and the time will be n plus 1, followed by if statement inside the for loop, so it will be cost2 and times equal to n times n plus 1. In if statement, there are cost 3 and 4 that the times will be n times n. So the growth rate functions can be calculated as Tn equals to cos 1 times n plus 1 plus cos 2 times n squared plus 1 plus cos 3 plus cos 4 times n squared equal to E times n plus 1 times B times n squared plus 1 plus C times n squared. So the big O(n) for the quicksort is O(n) squared. Thank you.
Assalamualaikum warahmatullahi wabarakatuh, and good morning to Dr. Intan. My name is Muhammad Khairul Irfan bin myself, and my metric number is B0320101092. I'm from the ITS S1G1. Today I will continue present my group project in slide time complexity case for the quicksort. For the time complexity case, there have three. The first is worst case, second is best case, and third is average case. For the worst case time complexity for the quicksort is n power of 2. For best case time complexity for quicksort is n times log n. Same to average case time complexity, also n times log n. Okay, now we go to next slide. Why our group choose quicksort better than merge sort? Okay, first is auxiliary space. Merge sort use extra space, while quicksort require a little space and exhibit good cacheability. That means merge sort is use extra space because it use more process because it merge the data and do more process than quicksort. So quicksort is better. And second is worst case. The worst case of quicksort or n power of 2 can be avoided by using randomized quicksort. It can be easily avoided without probability by choosing the right pivot. That means we can avoid the worst case of quicksort or n power of 2 by using the random of quicksort. When we use randomized quicksort, the probability choosing the right pivot is high. And lastly is locality of words. Quicksort in particular exhibit good cache locality, and this makes it faster than merge sort in many cases, like in virtual memory environment. Virtual memory environment is like RAM and so on. So it is similar with the reason in number one, because quicksort is really use little space of memory, while merge sort is use more space in virtual memory. So quicksort is faster than the merge sort because it use little space of memory, while merge sort is use more space in virtual memory. So that's all from me and our group. Thank you and assalamualaikum and bye.